In this video, I'd like to demonstrate a couple of unusual examples that could occur when you have an absolute value inequality. So when we look at the first case, we have this absolute value expression, but then we have some extra junk added on here and then the number on the other side. So the very first thing that needs to happen is we need to isolate the absolute value expression. So I'm going to subtract off 5 from both sides. Now that we've got our absolute value expression, absolute value of 3x, isolated, we can go back to the properties of absolute value inequalities. And this property says, if k is positive, then absolute value of x less than k is equivalent to x is less than k and x is greater than a negative k. But there's a very important condition here, and it says, if k is positive. And if we look at k, the constant, it's what's on the right-hand side of this inequality. And in our case, a -2 on the right-hand side means that k is not positive, and so we can't expand this absolute value inequality into two separate inequalities as we usually would if this value had been positive. So now what we have to do is think more intuitively about what's happening here. And when you take a look at this expression on the left, the absolute value of some expression is always going to be either greater than or equal to 0. So this is going to be non-negative. And on the right-hand side of the inequality, we have this -2, which is a negative number. And this is impossible. And therefore, this particular inequality has no solution. And again, if we step back and see what's happening here, in the original inequality, the left-hand side has this absolute value, which is a positive number, added to 5, and that is supposed to come out less than 3, which is impossible. So let's take a look at the second case, which looks similar. The only difference is that the inequality symbol is facing the other direction. And as before, we will isolate the inequality expression. And this time we end up with the absolute value expression, where absolute value of 3x is greater than a -2. And as before, let's bring back the rules that allow us to expand this absolute value inequality. So we say again, if k is positive, then this inequality can be expanded into two inequalities. However, again, k is not positive, so we have this condition violated, and we have to think more intuitively again about what's happening here. Now what we have on the left, again, is some non-negative, usually positive unless it's equal to 0, so some non-negative expression. But on the right-hand side, again, we have a -2, which is fully negative. And this time the inequality symbol is greater than, and a non-negative number is greater than a negative number, and that's true all the time. So x is any real number, and we can express this in set builder notation. Say this is a set of x such that x is an element of the set of real numbers. And that is the solution for this case. So it's important as we look at these absolute value inequalities that the very first step that we should do is to isolate the absolute value expression. And once we have evaluated the expression, then the second thing that we want to do is look at the constant. And once we've determined if k is positive, we'll use the rules for expanding our inequalities that we've shown above. And if our k is negative, then we will solve it by examining and then deciding whether we have a situation where we have no solution or we have a set of all real numbers as the possible solution.